Hello viewers, in today's session we are going to discuss another important and conceptual problem from finding out the equation of a plane under given conditions. So here we are going to solve this problem in which we have to find the equation of a plane which passes through two given points. The coordinates of the points are 2 comma minus 1 comma 0 and 3 comma minus 4 comma 5, and the plane is parallel to this line, and the equation of the line is minus x is equal to y is equal to minus z, right? So here we'll see how we can find out the equation of a plane which passes through two given points and an extra condition, that is the plane is given to be parallel to a line minus x is equal to minus x is equal to y is equal to minus z. So let us start. So now let us first draw a rough diagram of this problem, right? So we are given a plane, and this plane may be denoted by P, and here we are given 2 points. Let us take this point A as 2 minus 1 0, and this point B as 3 minus 4 and 5, right? And this plane is given to be parallel to some line, and this line is given by minus x is equal to y is equal to minus z. So this is our line L, whose equation is given by this one, right? Okay. So now the normal vector to this plane P is perpendicular to this line L, right? So this is our normal vector to this plane P, and this normal vector is perpendicular to this line L because the line L is parallel to the given plane, right? So here we have the angle that is pi by 2. So whenever a line is parallel to some given plane, then the line must be perpendicular to the normal vector to the plane P, right? Okay, now we know that the equation of a plane passing through some point x1 y1 z1 is given by this equation, that is A x minus x1 plus b y minus y1 plus c z minus z1 is equal to 0, right? So the equation of any plane which passes through the point x1 y1 z1 is given by this equation, where a, b and c are the direction ratios of the normal vector n, right? So A, B, C are the direction ratios of the normal vector n. So now let us apply this equation to these 2 points. Now see, this plane P passes through the point 2 minus 1 0. So let us replace x1 y1 z1 by 2 minus 1 and 0. So this equation now becomes A x minus 2 and b y plus 1, because here y1 is minus 1, and then we have c z minus z1. So z1 is 0, so here we have z minus 0, right? Okay, now this plane also passes through this point B, that is 3 minus 4 and 5. So now let us replace x, y and z by 3 minus 4 and 5, because this equation must satisfy this point also, because this point lies on the plane. So replacing x by 3, y by minus 4 and z by 5, this equation now takes the form A, and here we have 3 minus 2, then we have B, and here we have minus 4 plus 1, and here we have 5 minus 0, that is equal to 0. So now we have an equation in A, B and C, where A, B, C are the direction ratios of the normal vector to this plane P. So now we have 3 minus 2 is 1, so we have A, here we have minus 3B, and now here we have 5C, and that is equal to 0. So now this is our equation 1. So now we have utilized these 2 points to get this equation number 1. Now let us come to the equation of the line L. So here the line is given by minus x is equal to y is equal to minus z, and we can also write this equation as x over minus 1, y over 1 and z over minus 1. So this line may also be written as x minus 0 over minus 1, y minus 0 over 1 and z minus 0 over minus 1. So this equation is now of this form, that is x minus x1 over a, y minus y1 over b and z minus z1 over c. So this is the standard or the symmetric form of the equation of the line L. And this equation suggests that this line, it passes through the point, the origin, that is 0 comma 0 comma 0, and the direction ratios of the line, that is direction ratios of the line L, are given by A, B and C, and here we have A, B, C as minus 1, 1 and minus 1. So now this line L is parallel to the plane P, right? So the normal vector, that is n vector, is perpendicular to this line L. So the sum of the product of the direction ratios must be equal. So the direction ratios of the normal vector are A, B and C, and the direction ratios of the line are given by minus 1, 1 and minus 1, right? So here if we take the direction ratios of the line L as A, B, C, here we have A, B, C, then L is perpendicular to the normal vector, so we must have A times A plus B times B and C times C is equal to 0. So this is the condition for the perpendicularity of two vectors, right? So here A is minus 1, so we have A times minus 1, then we have B times 1, and then we have C times minus 1. So this is equal to 0. So now we have the second equation in A, B, C, that is minus A plus B minus C is equal to 0. So this is our equation number 2, and now we have to solve these two equations. So now we have two equations and three variables, that is A, B and C. So whenever we have this type of situation where we have the number of variables are greater than the number of equations, then we eliminate any one of the variable, right? So the first step is to select a variable and eliminate the variable from these two equations. So here it is easy to eliminate this variable, that is A, by adding these two equations. So when we add 1 and 2, then A and minus A get cancelled. Minus 3B plus B is minus 2B, and 5C minus C is equal to 4C, and this is equal to 0, right? So we can now write minus 2B is equal to minus 4C, and cancelling -2 and -4. Here we have b, and here we have 2c. So now we have b is equal to 2c, and we can here take some scalar lambda, right? And lambda is not equal to 0, and lambda is a real number, right? So now we can express b and c in terms of lambda. So b is equal to lambda, and 2c is equal to lambda. So c is lambda over 2. Right, now we have b and c in terms of lambda. So let us substitute b and c in any of these two equations to get the value of a in terms of lambda. Right, so we can take this equation number 2. So here we have minus a, b is lambda, and here we have minus c is lambda over 2, and this is equal to 0. So we have minus a plus lambda over 2 is equal to 0. So a is equal to lambda over 2, right? So now we have a is equal to lambda over 2, b is equal to lambda, and c is equal to lambda over 2. So now to get the equation of the plane, we can substitute a, b, c in this equation. So here we'll take lambda over 2, then we have x minus 2, and then here we have lambda y plus 1, and here we have lambda over 2, and z minus 0 is simply z, and this is equal to 0. Right, now see, lambda appears in all the three terms, and lambda is not equal to 0. So we can now write half x minus 2 plus y plus 1, and here we have half z, that is equal to 0. Right, so what we have done, we have divided both sides by lambda. Lambda is not equal to 0. So now we have this equation. Now multiplying this equation throughout by 2, we have now here x minus 2 get cancelled, and here we have 2 times y plus 1, and here 2 get cancelled. So we have simply z, and this is equal to 0. So we have x plus 2y plus z, and here we have minus 2, and here we have plus 2, and this is equal to 0. Now minus 2 and 2 get cancelled, so we have x plus 2y plus z is equal to 0. Right, so viewers, this is the equation, or the required equation of the plane, which passes through these 2 points and parallel to this line minus x is equal to y is equal to minus z. Now see, the direction ratios of the normal vector are given by a, b and c, right? So we have a, b and c as lambda over 2 lambda, and here we have lambda over 2, right? So if we multiply here throughout by that is 2 over lambda, then we have here 1, and here we have 2, and here we have 1, right? So the direction ratios of the normal vector are 1, 2 and 1, and which is quite evident from this equation, because here the coefficients of x, y and z are given by the direction ratios of the normal vector. So here we have 1, then we have 2, and here we have 1, right? Because whenever the equation of a plane is represented as ax plus by plus cz plus d is equal to 0, then a, b and c are given by the direction ratios of the normal vector to the plane. So in this case, the required equation of the plane is given by this equation, that is x plus 2y plus z is equal to 0. And from this equation, it is clear that the plane passes through the origin, because this equation satisfies this point, that is 0 comma 0 comma 0, right?